Hi, welcome to another edition of Fun with Conceptual Physics, the Momentum Edition. Put your name on this. I'm grading this and collecting it. Whatever I write, you are to write. So, let's begin. Which has greater mass, a truck or a skateboard? The mass of the truck is clearly greater than the mass of the skateboard. Whether you're in motion or not doesn't affect mass. Mass is your inertia. It's how much stuff you have. Remember, mass never changes anywhere. So if you have a truck, it's clearly has more mass than a skateboard. Now momentum is inertia in motion. Who has more momentum? Well, the truck is at rest, so the skateboard's momentum has to be greater than the truck's. The truck has zero momentum. I don't care if it's really heavy, it has no momentum if it's at rest. Next, impact is the force acting on an object. Impulse is a force times a time. Now, something I want to clarify, the last exam was a little weird. If two things collide, the forces between A and B are the same. However, when object A hits a bale of hay and object B hits a concrete wall, the force on B will be greater than the force on A. Many students are getting confused. This isn't between two objects. This is one object and another object hitting different items. If something's hard, the force will be greater. If A and B hit each other, the forces are the same. But A is hitting hay, B is hitting a wall. The force on B will be greater than the force on A. These are different concepts, so I want to reiterate that. I expect that on this handout. So again, I'll take my time. When A and B hit each other, the forces on each other are the same. But when A hits hay and B hits a wall, the force on B will be greater than the force on A. These are not hitting each other, so the forces cannot be the same. Moving on, impact is the force. An impulse is a force times time. All you do is multiply two things. If you increase time, impulse will increase. This is just saying all you're doing is increasing time. You'll get a bigger impulse. Please understand that. In a car crash, so you got a car, I'll draw a little car. It's about to hit a wall, a brick wall. I'll make it brick this time. When the car hits the wall, if you can extend the time during impact, what happens? Well, if you have a big time, you're going to have a small force act on you. Or you could hit for a short time and you'll have a big force. What happens? The force decreases if you can make time increase during a collision. This is not a collision over here. Question 3 and question 4 are two different things. This is saying, what if you made the time during the impact of a wall longer? The force would decrease and you would, no injury. So you can have a big time or a small time. It's up to you. If you have a big time, you have a small force. If you have a small time, you have a large force. Bouncing. We talked about that. When you bounce, there are two impacts. So when a ball goes down, it hits the floor and it stops. That's the force number 1. Then the ball bounces up. That's force number 2. So there are two impacts during bouncing. One to stop you and one to throw you back up. So there are two forces or impacts during a bounce. They mean the same thing. This next question, take a second and read it. Okay, so at this point, some important information. You're going at this speed. This is the time. Notice it's a decimal. I'll write it a little bit bigger. 0.05 seconds. And this is the mass of the car. So these are calculations, and I'll walk you through a few of these, and you're going to do several on your own. In impulse, write this down, equals a change in momentum. Impulse is force times time. Change in momentum is m, change in velocity. It's going to take several of these to do several of these. Your change in velocity, right, F times time equals m, parentheses, v final minus v initial. Now you're going to come to a stop. Now we're going to drop any negative signs. If you're going at 20 and coming to a stop, what's your change in velocity? How much velocity do you lose? Right, lose down. Well, your change in velocity is going to be 20 meters per second. You lose all your velocity. You lose it all. You're going at 20 and you come to a stop. What's your mass? 700. So you have F times 0.05 equals 700 times 20. You're going to do this in 2 steps. First step, you're going to multiply these two numbers together. Then you're going to divide. So you multiply first, then divide. So I'm pausing for a second to let some people catch up. And I'll reiterate. You're going at 20 and coming to a stop, so you're going to lose all your speed. That's your change in velocity. An impulse can change your momentum. So I'm going to take 700 see where it's clearest on here. There, maybe there. 700 times 20, and that's a big number. That's 14,000. So I have F times 0.05 equals 14,000. First thing I did was multiply those two numbers, the M and the delta V. This is M, that's change in velocity. I'm going to lose all my speed. Now I'm going to divide both sides by 0.05. So in your calculator, you got to be careful. Don't mess this up. This is in the top, so it's the numerator. That's first, this is second. This is a simple fraction. So I'm going to take 14,000, 14,000 divided by 0.05. That's on top, that's on bottom, and hit equals, looks like 280,000, and the units are newtons. This is a force. My force will be 280,000 newtons. That's a big force. That's pretty big. Well, the guy was going pretty fast and hit a brick wall or something, a bridge support, which is usually concrete. So it probably destroyed their car. So let's do another one. Flip the paper over. In this problem, a driver lost control of his vehicle and plowed in barrels at 30 meters per second. It's going to come to a stop. Here's the time, here's the mass, and your delta V, you're going to lose all your speed, is 30 meters per second. So you do the same form again. F times time equals m delta V. You plug in some numbers. F, now this is 1 second, so that's a nice number, equals 700 times 30. You do the rest from there, get an answer, and the answer should be in newtons. Now, wait a second, don't calculate anything else, because I want to do a few more of these. This is the mass for the next problem. The person stopped, so your change in velocity will be 5. Your time is 1 second. And they want the same formula again, where you know this number, and this number. Multiply these first, then divide. Let's move on. You can do that on your own in a second. So you're going to find a force equals something newtons. Over here this time you do know the force, you know the mass, and the time. They want to find the change in velocity. So this time Ft equals m delta V. You're going to know all the numbers over here. This time you're going to divide this way. So if you plug in the numbers, you have 400 newtons this time. Your time is 0.03 seconds equals m. And you're going to, you know the mass of the ball. 0.3 kilograms times delta V. So this time you'll multiply these two numbers and divide by 0.3. and you'll find a change in velocity, and it will be something meters per second. For problem 10, we're going to skip that. Over here, you know the mass. You're going to come to a stop, so this will be your delta V, and that's your time, and you want to find force again. F times time equals m delta V. So this time you'll want to find that again. And last but not least, you do this one all on your own. This time you're looking for time. And the time will be something in seconds. So this worksheet's due at the end of the hour. And if you get done with this, you have 2 homework checks. Those homework checks need to be done, or I will not review with you tomorrow.